Welcome to the 2.1 multiplying fractions video. The key idea of this section is to multiply the numerators and multiply the denominators. So if I had 3/7 times 1/2, it would look like this, and you can set it up this way. 3 times 1 over 7 times 2. You're just going straight across on both of them. So it's a lot different than adding, because with adding you have to find a common denominator. We often say that multiplying fractions is a lot easier than adding and subtracting fractions. So I would just go straight across. 3 times 1 is 3. 7 times 2 is 14. And so that would be my final answer. We algebraically write it like this, where we have, let me find my pointer, where we have A over B times C over D, and it just equals A times C over B times D. This doesn't actually mean anything. We're just getting you guys used to thinking about algebraic terms with variables, meaning letters, using the dot instead of the X. So if you see, it looks identical to what we have here, but yet we're using letters as variables. Example 1, multiplying fractions. Directions for something like this would look just like that. Find 1/5 times 1/3. So you just simply write it out like this. And I just like to go straight across and show you that 1 times 1 equals 1. And going straight across again, 5 times 3 equals 15. So my answer would be 1/15. Pretty simple. Example 2, multiplying fractions with common factors. So we learned about factors in chapter 1 and how that a factor of the number 4 would be 1 and 4 and 2. So 1, 2, 4. So directions would look something like this, 8/9 times 3/4. So you would rewrite your problem, and I did it color-coded like this so you can see and recognize the pattern. So I've got 8/9, let me get my pointer, 8/9, oh, and I put the wrong thing in there. Let me erase it real quick. Sorry. So 8/9 times, my bad. 8/9 times 3/4. So what I'm going to do is I'm going to show you how to cross simplify or factor out these numbers. So basically all you're doing is you're recognizing by looking across and across. So it's a crisscross problem here. What do I have? I got 8 over here, and if I look over here, I have 4. So we can use a common factor of 8 and 4 to divide it out and divide out those common factors. It's a lot easier to solve, and it gets us down to a simplified version, okay? So let's look at, let's see here. Sorry, I'm playing with my buttons here. So I've got 8 and 4, and a common factor of the two is 4. So because a common factor is 4, I'm going to divide that out. So I'm going to rewrite this. If I divide 4 by 4, because 4 can go into 4 itself, it can also go into 8. I could use 2, it's a common factor, but it's not the GCF. It's not the greatest common factor of the two. So because it's not the greatest common factor, I'm not going to get a simplified version of this. So what this would look like, well, let me show you the other two as well. I've also got 9 and 3, and 3 is the greatest common factor of 9 and 3. So those two can factor out. So I can divide this by 3, and I can divide this by 3. So what that does is I take 8, I'm starting up here. I've got 8 divided by 4, which gives me 2. And I've got 9 divided by 3, which gives me 3. And then over here, I've got 3 divided by 3, which gives me 1. And I have 4 divided by 4, which also gives me 1. So what I did was I just factored these out by using a common factor. I used a common factor of 4 for 4 and 8. Use a common factor of 3 for 3 and 9. You can only do this crisscross. That's why I put the arrows over here. You can only crisscross. You can't go this way. Even if they are common factors, it doesn't matter. They have to be crisscrossed. So sometimes I think of just follow the multiplication sign. Now that I've got these factored out, I can go straight across, like I learned in example 1. 2 times 1 is 2. 3 times 1 is 3. My final answer to this problem would be 2/3. So we're going to look at this one just for better understanding. I'm going to try and see what numbers can I factor out. So I look at my 7 and my 2, and I look and I say, there's no common factors of 2 and 7 together. Then I look at 3 and 3, and I say, well, obviously they're both the same number, so the greatest common factor of both of them is 3. That means I can divide it out, both sides, by 3. I can't do anything to my 2 and 7, so I just leave them. So now I've got 3 divided by 3 is 1, and I keep my 7 because there's nothing I can change about it. I keep my 2 because there's nothing I can factor out or change about it. 3 divided by 3 is 1. So what happens is I just go straight across to do my multiplication. 1 times 2 is 2. 7 times 1 is 7. So it equals 2/7. I'm going to show you this way if I were to just solve it and not do any of the factoring out or the cross simplifying. If I go straight across and straight across, I've got 3 times 2, which is 6. And I have 7 times 3, which is 21. Now I'm left with going through all my divisibility rules to figure out which one can I divide these out by. And if you look at them, I can use the divisibility rules of 3. Can 3 evenly go into 6? Yes. Can 3 easily go into 21? Yes. So I would divide these both by 3. 6 divided by 3 is 2. 21 divided by 3 is 7. So what's happening is this provides me with an extra step of trying to use divisibility rules to rule it out. If I just cross simplify like I did up here or factor them out, then I can do it right away, do my problem, and move right on. So I feel like this one provides an extra step for you that you don't actually need. So if you just factor them out and use a GCF, then you can move on quickly. So we're going to skip one of the examples because it's a real life application. We'll come back to it. But this one is multiplying a fraction and a mixed number. We need to write each mixed number as an improper fraction, and then we can multiply as you would with normal fractions. So it looks something like this. So find 1/2 times 2 3/4. I'm going to start with 1/2 because nothing changes in that situation. And what I'm going to do is I'm just going to pull this down and show you what it's like. So we did this before, but you're going to take and make this into an improper fraction by saying 4 times 2 is 8 plus, that's a plus sign, sorry, plus 3 is 11, and it's over 4. So actually what happens is 11/4 actually does equal 2 3/4. It's an equivalent fraction. I know we talked about that before, but we'll actually get into that later. So now that I have these two numbers like this, nothing has changed except for I went from a mixed number into an improper fraction. I made equivalent fractions here. I left my 1/2 the exact same. And now what I'm going to do is I'm going to look and see if there's anywhere I can factor by crossing, by doing a cross factor. And obviously I can't. I've got 1, and I've got 4, and I've got 2 and 11. So I'm just going to go straight across and do 1 times 11 is 11. 2 times 4 is 8. Now, we talked about this a little bit. If I leave this as 11/8, you're not putting it back into a mixed number, and it would probably cost you a 1/2 point on a test. So now I need to, I'm just going to kind of make a little mark like this, take 11/8 and think to myself, how many times does 8 go into 11? 1 whole time. How many do I have left over? So I would take 8 times 1 is 8. So 11 minus 8, I get 3, and then I leave the number 8 as my denominator. So my answer to 1/2 times 2 3/4 is 1 3/8. All right, example 5 is just multiplying mixed numbers. So it's really the same concept, only now you have two numbers that you have to make into improper fractions. So it would look something like this. So all I would do if I had 1 4/5 times 3 2/3, I'm just going to make these into improper fractions by saying 5 times 1 is 5 plus 4. So I've got 9. I leave the same denominator. So if you're confused, watch what I do here. 3 times 3 is 9 plus 2. So I got 9 plus 2 is 11. That becomes my numerator. And I leave my 3 as my denominator. So now I just took my two improper fractions. I made them into improper fractions. I'm sorry, I took my two mixed numbers and I made them into improper fractions. So now I'm going to look, is there a place where I can do my crisscross and I can do some cross simplifying. So I'm going to look here. I've got 3 and 9. So obviously 3 and 9, 3 is a factor of 9. So I can divide out 3. And I can divide out 3 over here. Again, whatever I do on one side, I got to do on the other. And then I'm going to look at this way. I've got 5 and 11. So there's no common factors between the two of those numbers. So now it will look like this. 9 divided by 3 is 3. I leave my 5. Leave my 11. 3 divided by 3 is 1. So now I just got to a point where this will be as far as I can go as far as simplifying it. 3 times 11 is 33. 5 times 1 is 5. Again, if you leave it like this, it would be minus a half a point. But if you take it and make it into a mixed number, how many times can 5 go into 33? 5 times 6 is 30. So I've got 6 whole times. 33 minus 30 is 3. And I put it over the same denominator of 5. So I have 6 3/5 would be my answer. And that's going to conclude your video. I don't have any practice problems for you. We will work on stuff in class tomorrow.